We'll talk about that a little later. Radians. So, let's see if we can do this here. Draw a circle as perfectly as I've drawn one here. If you can.
About that size.
Draw a perfect circle, as only I can do. Okay, now locate the center and draw a radius. Now this radius has a certain length, yes?
Yeah.
We're going to call that R. Where the radius meets the outer edge of this circle right here, I want you to draw a segment of the exact length of R, or just your best estimate, and let's call that R. You guys okay so far?
R.
Now, if we were to somehow, if we were able to take this vertical segment and wrap it around the outer edge of a circle, using the exact same length, so R would pretty much be wrapped around right to here. You guys okay with that assessment?
Yeah.
So all I did was I took R, I bent it around the outer edge of the circle, so that also has a length of R. You still okay?
Mm-hmm.
That, my friends, is equal to 1 radian. That's what a radian measure is. Radian measure is you take the radius of the circle, you wrap that around the outer edge of that same circle. That's 1 radian. Okay. Now, where's the marker? So if this is 1 radian from here to here, this would be roughly 2 radians, right? And then this is half a circle. 3 radians would put us about right here. You guys okay with that? There's 1 radian, there's 2 radians, there's 3 radians. So half a circle is almost 3 radians. It's 3 radians plus a tiny bit more, correct?
Yeah.
What's a number that's very famous in mathematics that's 3 plus a little bit more? Pi. So half of a circle is pi radians. Pi radians is half a circle. What would a full circle be? 2 pi. A full circle is 2 pi. Okay. And again, this is just stuff that you should learn last year. Okay. A radian is just an arc length that's equal to the radius of that size of a circle. Okay. So, really the most important thing here is remembering how to convert a degree measure into a radian measure. That's really the important thing here. So converting, if I asked you to convert, I don't know, 70 degrees, you multiply it, I think I heard it over here somewhere, pi over 180. Sorry, I just heard a lot of things going on over there. Why does this work, by the way? Why does this work? It cancels out the degrees. That's true. That is true. The degrees cancel out, but
It's like conjugate it by 1. It's pi and 180%.
that's more what I was getting at. Isn't pi and 180 the same exact thing?
Yeah.
So what is pi divided by 180? 1. All we're doing essentially is taking 7 degrees and multiplying it by 1. This is dimensional analysis they use in physics all the time to convert centimeters to feet or whatever it is. So all we're doing is canceling one unit of measure and putting it into a different unit of measure. So we get 70 pi over 180, which is 7 pi over 18. Okay? Going the other way, if I gave you something like 3 pi fifths, and I wanted you to convert that into degrees, what would you do? This one is 180 over pi, because now the radian unit of measure cancels out. The radian unit of measure is gone. can even do this without a calculator if you wanted. How many times is 5 going to 180? 36 times 3. 5 goes into 180, 36 times 3. 108. Yeah. So it's 108 degrees. So your homework starts off with this, converting radians to degrees, degrees to radians. Do you think you can handle that? All right, moving on. The homework then goes into the definition, or definitions, of the trig functions. This you ought to remember. Sine theta, cosine theta, tangent theta. What's the definition of the sine of an angle theta? The sine is opposite over hypotenuse. The cosine. Have you seen? Are you talking about the key and peele? Maybe I'll show you that one too. Adjacent over
Zane stole my joke last week.
hypotenuse, and then tangent is opposite over
Adjacent.
adjacent. If you want, if it helps, you can remember the goofy phrase soka
That's all I remember.
toa. Or as one of our math teachers here, I'm not going to say who, came up with a little saying, some old hippie caught another hippie tripping on apples. That's not what they said, but that's what I'm going to say, because it's more appropriate for your young minds. Some old hippie caught another hippie tripping on apples.
Oh yeah, he says. Of course he does.
Tripping on apples, like people do. What are the other 3 trig functions? What do you remember?
Tripping on adjacent.
Cosecant, secant,
Oh, I remember these.
and cotangent. These are less familiar to you probably, but you're going to become familiar with them. You're going to be besties here in a
I'm
little
so
while.
familiar with them. You got no idea.
We used these to solve those thingies last
Yep.
year.
Hypotenuse over opposite, because the cosecant is the reciprocal of the sine.
It's 1%.
It's 1 over sine. The secant is the reciprocal of the cosine, so it's hypotenuse
I remember that cosecant goes with sine.
over adjacent.
They'll go. Cosine, cosecant, cosine.
And the cotangent is reciprocal of the tangent, so it's adjacent over opposite. Okay? There are some additional definitions I want you to write next to these if you still have room, which you guys are going to see more of at this level. These definitions are like Algebra 2 definitions. They're good definitions, but you're way beyond that. Okay? The sine is y over r. The cosine is x over r. And the tangent is y over x, assuming that x is not 0.
Plus.
Okay. And then the cosecant, the secant, and the cotangent are just going to be the reciprocals of these definitions. So the cosecant is r over y. Again, assuming y is not 0. The secant would be r over x. X cannot be 0. And the cotangent would be x over y. And y cannot be 0. Ooh, it looks like they are going to get into some of the identities.
I hated them.
Heck to the yeah, that's my favorite unit last year.
Yeah.
That's great. It's what we're gonna do.
It totally, my mind was totally in another world.
I know. You guys are nerds.
This is my brain.
Hold on, I'm just verifying that we're going to have to do some identities.
Yeah, that's right.
I hope we do.
I've known Brayden longer. I've known Brayden longer since preschool. Get away walls with my preschool. Shut up. Shut up, Shane. Dang it.
Oh, dang it.
He's mine. You can't have him. Stop. He's already mine.
No identities yet. Oh boy. You might get lucky. Dang, there's no identities. You guys lucked out. We will see him later. Let's do some examples.
I was on the resistance first.
Example 1. Draw this graph. And then on the graph that you have just drawn, draw this angle. And then actually on the angle, rather than putting an arrow on this side, put a dot right here. And let's say that the location of this dot is 4, -3. And angle theta would be the angle measured in the positive direction out here. And you need to find all 6 trig functions for theta. All that stuff, opposite over adjacent, opposite over hypotenuse, that's great if you have a right triangle. We don't have a right triangle here. Okay, so we're going to use these alternate definitions, the x over y, or the y over x, or the x over r. We're going to use that definition, because we have an x and a y, yes?
Yeah.
What is the r? Do you remember what r is?
R
It's the distance from the origin to the point 4, -3. That's r. So the first thing we got to do is find r.
Let's find R.
Here's r right here.
All
Found
it
it.
is.
What's the length of r?
5.
A squared plus
B squared.
b squared. And then you square root. This is Pythagorean theorem. Nothing more than Pythagorean theorem. 4 squared is 16. -3 squared is 9. 16 plus 9 is 25. Squared 25. 5 is 5. So we got lucky. We got a 3, 4, 5 triangle here. R equals 5. So the sine of theta, cosine theta, and tangent of theta. As long as you can remember their definitions, you should be good to go on these. What's the definitions? The sine is y over r. So it's -3/5. The cosine would be x over r. And the tangent would be y over x. Now I want to bring up something, before we do the other three, I want to bring up something else that needs to be mentioned here. Write this on your graph. Write that on the graph. This is worth bringing up. Hopefully you'll recall this once we get into it a little bit. Some trig functions are positive in certain quadrants. Some trig functions are negative in certain quadrants. Remember this?
Yeah.
The phrase that a lot of teachers use is all students take calculus. That helps you remember. All students take calculus. So we've got sine negative right now. We've got to make sure that this makes sense. Our angle is in the 4th quadrant. Does it make sense for the sine to be negative in 4th quadrant?
Yeah.
Yes, it does. What should be positive in the 4th quadrant? Cosine. Is our cosine value positive?
Yeah.
So that's always worth keeping in mind before you just mindlessly circle an answer thinking it's correct. Always consider, is it really correct? Does it make sense? Okay. The other 3 trig functions would just be the reciprocal. Cosecant of theta would be -5/3. The secant of theta would be 5/4, and the cotangent would be -4/3. Okay. Your homework then gets into these kind of problems, which I think are kind of fun. Oh, we should just skip these. They're too easy for you.
Yeah.
No, Mr. Hub.
I'll show you an example of what they are, but we don't need to spend much time on them. Draw a right triangle.
Let's do them.
Make sure it's as perfectly drawn as mine.
Oh my gosh.
Use this little angle.
I did not. This is freehand. This is freehand, y'all.
That's freehand, y'all.
So, 1, 3. I don't even know why they put this in here. This is like algebra 2 stuff.
Oh, I love these ones.
Alright. I'm embarrassed to even give you this problem.
That's great. I don't know how we're gonna solve this. I don't know why you're saying it's
It's
great.
impossible, actually.
Impossible?
Unsolvable. There's not enough information. 9 minus 1.
That's impossible.
I was new math, had some stuff that was fun.
Come on now.
We could use the Pythagorean theorem.
Why do we need to use Pythagorean theorem?
Well, we don't
To find the adjacent length.
We could use sine.
Find the adjacent length using Pythagorean theorem. It should take you like 5 seconds. Come on, go.
Okay. Square root of 3.
Find the adjacent length. It's probably not going to come out to be a nice number. What are we getting? 2 squared is a 2. I agree with you there. We have a squared plus 1 squared equals c squared. That means a is equal to the square root of 9 minus 1. So a is equal to the square root of 8, which means a is equal to 2 root 2. Very good. So what is the tangent now?
1 over 2 square roots of 2.
1 over 2 squared is a 2. You're not going to want to leave it like that.
No, we have to rationalize.
You have definitely got to rationalize. How do you rationalize?
2 square roots of 2 over 4 times 2.
Square root of 2 over 2? I'm sorry, square root of 2 over the square root of 2. So the final version is the square root of 2 over.
Oh, wait. Scratch that 4.
Square root of 2 over. Oh.
That's what I got, but it's multiplied.
All right. Let's get into this. Evaluate without
Oh, jeez.
a calculator.
Put that as later.
Evaluate without a calculator. So I want you to do sine theta, cosine theta, and tangent theta for the following theta values. For part A, let's do theta equals 2. Let's do 30 degrees. Theta equals 30 degrees. Do you remember how you did this last year in pre-calc?
Mm-hmm.
How did we do this last year in pre-calc?
Those triangles that were nice.
We could use the special triangles. We're trying to find the sine, cosine, and tangent of 30 degrees. Without a calculator,
We use special triangles.
we could use special triangles.
But I'm assuming this one isn't going to come.
We can use the unicircle. I'll show you that in a second. But the special triangles are only useful if you remember them.
I remember all of them. 30, 60,
30, 60, 90. If this is 30 degrees and that's 60 degrees,
1, 2,
Square root of 2x and square root 2 square roots of x.
So, it's a 30, which 1, 2 square root.
1, 2 square root of 3. What you were talking about isn't incorrect. If this is x, ooh, not that.
That was cool though.
What you're saying isn't wrong. If this is x, then this is just double that, because the hypotenuse is always double, and this would just be x times square root of 3. But it's just to keep it simple, we can just do 1, 2 square root of 3. So, what's the sine, cosine, and tangent? Sine 30? Sine 30 is? Come on now. 1 over 2. Cosine of 30?
Square root of 3 over 2.
Square root of 3 over 2. Tangent
Square root of 3 over 3.
is going to be 1 over the square root of 3, which is square root of 3 over 3. What's that? What's another way to do it? Unit circle is another way. So let's try a quick little unit circle. Oh man, I can't even draw a graph. I had a unit circle somewhere.
Yeah, I thought you did too. I stole it last year.
Somebody came in and stole my unit circle.
I stole it. You were so rude.
You stole it? Well, anyway,
You failed the quiz.
unit circle is not a bad thing. If we have 30 degrees, 45, and 60, 30 degrees, 45 degrees, and 60 degrees. You're really going to have a good memory, though, for the unit circle.
Square root of 2 over 2. 1 over the square.
Hey, let's go. You guys need to focus. The 45 one is easy to remember. Square root of 2 over 2, comma. Square root of 2 over 2. What do you remember about the 30 degrees? So what were the x and y coordinates?
1 over 2.
If it works, it works. So what's the coordinate then?
Oh yeah.
Okay, and then the 60 degrees is the exact opposite. It's 1/2 square root of 3 over 2.
Okay. You guys, I actually would recommend that you become more familiar with the unit circle. Okay. Here's why.
If I had asked you now for part B to do, let's do a different color here, negative 60, theta equals negative 60 degrees. Using the unit circle is going to be a little bit
Better for you, I guess, if we're doing negative angles or angles that are larger than 90 degrees.
Because we could still use the unit circle, you just have to be a lot more clever about your answers. What would the sine of negative 60 be?
Negative 60 is 270.
Where is negative 60?
Or no, not 270. It's 2.
Negative 60 is right here. Negative 60 is right there. What's the angle going in the other direction called coterminal? So we could also say that this is 300 degrees going this way.
Maybe that's the reference.
And then we could just do, and then 60 degrees would be, do you remember reference angles from last year?
Yeah.
60 degrees would be the reference angle. So we can use the reference angle. That's called theta prime. Theta prime is 60 degrees. So if we want to use the reference angle, that's fine, but you have to remember some of the positives and negatives change. What would the sine of 60 degrees if we're using 60 degrees as a reference angle? What's the sine of 60?
Square root of 2.
How do we use the unit circle for the sine of 60? It's the y value, so the square root of 3 over 2, but we're in the fourth quadrant now, right? And what was that phrase all students take? Calculus. We're doing the sine of 60 in the fourth quadrant, so the sine has to be negative, so it'd be negative
square root of 3 over 2. Okay, the cosine of 60. Remember, the cosine is equal to the x value, so at 60 degrees, the cosine is 1/2. But we're in the fourth quadrant. What do we know about the fourth quadrant? It's positive in the fourth quadrant because we're in the cosine region there. So cosine of 60 can still be 1/2. Tangent? Using the unit circle for tangent can get a bit funky. If you do y over x, you've got square root of 3 over 2 divided by 1/2. Square root of 3 over 2 divided by 1/2. But if you're dividing by 1/2, that's the same as timesing by 2. The 2's cancel, so it's the square root of 3. But we're in the fourth quadrant, so it's got to be negative. It's negative square root of 3. So there are a whole bunch of problems like this to practice on your on your homework. Without a calculator, yeah. You either use the unit circle or you use the special triangles. Yep. Okay. Let's see, where are they going now? Ooh, solving trig equation. That's the next part of the assignment. We're going to do two different types. Basic, meaning very, very simple. And not so basic, meaning simple, but not just really simple, just simple. So, here are some basic ones that you should be able to do in your sleep. Solve something like sine theta is equal to square root of 3 over 2 for all theta. 0 is less than or equal to theta, less than or equal to 2 pi. Well, what do you remember from last week?
Well, it's positive.
We can solve this kind of reasoning our way through it mentally. We could do that.
Just the top half of the circle.
Where is sine positive? That's a good question, because the sine of theta came down to be positive square root of 3 over 2. So where is sine positive? Quadrants 1 and quadrants 2.
So we could maybe reason our way through this answer. Looking at this unit circle I drew up here, what angle for theta would have produced a sine value square root of 3 over 2?
60 degrees.
60 degrees would have produced a sine value square root of 3 over 2. And what corresponding angle in the second quadrant would have given the same y value? Square root of 3 over 2.
It would have been right over here, and that's 120 degrees. You follow? Solving trig equations. The norm is in radians, by the way. That's the norm. So just kind of by thinking our way through it, we can say, all right, theta could be 60 degrees or theta could be 120 degrees, but we need to turn those into radians. What are they in radians? Pi thirds and 2 pi thirds. Yep, I think that is right. How would we have done this using more algebra instead of reasoning skills? Let's do it again. We have the sine of theta is equal to square root of 3 over 2. What would we have done? Inverse trigonometry. The inverse sine on both sides. Inverse sine cancels the sine. Theta is equal to the inverse sine of square root of 3 over 2. Now, what do we do from there? We could try it on a calculator. We are allowed to use them now.
You have to make sure your calculator is in radian mode.
Well,
Or do you want it in degree mode?
we want the answer in radians, but using the calculator, it's best to put it in degree mode. I'm going to check my mode here. It's in degrees. If I do the inverse sine of, what was it, square root of 3 over 2. Oh, no. There we go. Divided by 2. 60 degrees. The one problem that I need to caution you
Of just using the calculator is you might think, all right, the answer is 60 degrees. Moving on. Is the answer just 60 degrees? No, you got to remember, the calculator is a function machine. One input gives one output, but these are not functions. Trig equations are not functions. One input could give multiple outputs. So you got to understand, all right, it's only giving me the first quadrant answer. Where else is the sign positive? Second quadrant. Okay? And that's only in the first 4 quadrants, 0 to 2 pi. If that restriction weren't here, 0 to 2 pi, how many answers would there be? Infinite. You remember last year you had to do plus the 2 pi k at the end of some years? Okay, that's if that domain restriction wasn't there.
So according to this, we get the same answer. Theta equals 60 degrees. And then using your brain, you'd have to reason, all right, it's also got to be 120 degrees. Change them into radians. I want to show you something else. It's kind of cool. If you're in radian mode, just hit mode, and then there's radian or degrees right here. So if you're in radian mode, and I do the inverse sine of square root of 3 divided by 2, what's it going to tell me?
What the crap is that? That's 60 degrees in radians, right? But what is 60 degrees in radians? This is actually something you guys want to pay attention to. It's pretty cool. What is 60 degrees in radians? Pi thirds. Is that pi thirds? Well, here's a little trick I want you to consider.
If I divided away pi and then turn this into a fraction, what does it tell me?
Oh my goodness.
You guys see what I did? Why did I divide away pi? Because pi is on the top of pi thirds. I divided away pi on the bottom, so now pi is gone. I turned it into a fraction. So that's telling me 1.047195551. If I divide away the pi and make it into a fraction, what is it? Pi thirds. Pretty cool, huh? Anyway, you guys are hard to impress.
Man.
Whoa.
There you go. At least act like you're impressed.
Mr. Hunt, how do you fit so much knowledge in your head?
I had to reduce the amount of hair on my head to fit in more brain power. Let's do some more complicated ones. Complicated. 2 sine squared minus 1 equals 0. Same directions though, we're only solving for theta between 0 and 2 pi. Actually, we don't need to equal 2 pi, because 2 pi is the same as 0.
Alright, we did tons like this last year. What do you remember? Add 1, divide by 2, square root, because we're going to eventually have to use inverse trigonometry like we did on this one, and in order to use inverse trigonometry, we have to isolate the trig function. Okay? So if you add 1 divided by 2, you're going to get sine squared equals 1/2. Now if you square root both sides, you're going to get sine. Oh, what am I doing? There's got to be a theta symbol in there. Sine theta, there we go. Sine theta is equal to plus or minus. This is the one thing that you guys forgot last year. When you square it, it's plus or minus, you ding-dongs. Plus or minus square root of 2 over 2. So this is actually 2 equations we need to solve. So I'm going to separate this into 2 equations. We got to solve the equation sine of theta equals positive root 2 over 2, and then we got to solve the equation sine theta equals negative root 2 over 2. How is that to be done?
Yeah. Basically, we took a complicated equation, or what may be perceived as a complicated equation, and split it down into 2 very easy equations to solve. Okay. Sine theta equals root 2 over 2. Most of you could probably pop this out without having to use a calculator. Where is the sine of theta equal to root 2 over 2. 45 degrees in the first quadrant. Where else?
135.
135 in the second quadrant. So theta equals 45, which is pi 4. And theta could also equal 135 as a radian measure.
3 pi 4.
3 pi 4. And then over here, sine of theta equals negative root 2 over 2. This is just the corresponding angles in the third and fourth quadrant. So it'd be 215 and whatever the one is in the fourth quadrant. Theta is going to equal 5 pi 4. And theta equals 7 pi 4ths.
Isn't trig so awesome?
That's why they gave it such a sweet name.
I gotta give you guys a challenge here. This isn't challenging enough for you. Holy smokes. Alright, good luck. This I'm going to classify as super.
Uber. Say Uber.
Uber, alright. Uber. Complicated. Cosine squared theta plus sine theta equals 1.
We are probably going to have to end up using some identities here.
Subtract cosine squared. Which gives you sine equals sine squared.
We had a pretty good idea over here. Go ahead.
You're going to subtract cosine squared on both sides, so it's 1 minus sine of theta equals 1 minus cosine squared of theta.
Okay, stop there. Stop there. Did you guys hear what he said? This is a great idea. Subtract cosine squared on both sides. So now we have sine of theta equals 1 minus cosine squared theta.
Good things are amazing. 1 minus cosine squared.
That's the one. You guys, that's probably the most commonly used trig identity, is called the Pythagorean identity. Sine squared of theta plus cosine squared of theta equals 1. This is the most widely used trig identity. Okay? If you subtract cosine squared on both sides, then you get sine squared equals 1 minus cosine squared. That's exactly what we have here. 1 minus cosine squared is equal to sine squared. So we're going to make the, that's what you were thinking, right? Okay. So you make the replacement. Sine theta equals sine squared of theta. Well, at least we got rid of cosine. We have all sine. What does sine squared of theta mean? It really means sine times sine. I want to bring up something that is very important for you guys to understand, because I do see this from time to time. And it's a pretty big mistake. What about dividing by sine? I want to talk about this. You can't do this. This can't be done. I know it seems like it's tempting, because if it's sine squared and you divide by sine, that gets rid of one of the signs, right? Yeah. And then over here you just have a 1. So it seems like a fantastic idea. Why the crap doesn't it work? You got your hand raised. What do you think? Sine is an operation. Keep going. You can't divide by an operation. You are correct. Technically, you are correct. Why though? What can't we divide by ever, unless you're Chuck Norris? 0. You can't divide by 0, yes or no?
Yes. No.
You can't divide by 0, correct? Well, do we know what theta equals? What if theta does equal a value that turns sine of theta into 0? Then wouldn't this be a problem?
Yes.
That's why you can't divide by expressions like this with unknown variables, because you don't know what x is. It might turn out that theta is something that turns sine into 0.
This is an invalid operation. It's tempting, but it is no good.
Multiply by 1 over.
Well, let's multiply by 1 over sine. Yeah. Still no.
Okay. Wait.
Let me show you something that you could all solve almost immediately. What if this were an equation to solve? How would you solve this equation? You subtract x, and then you would factor out the x, wouldn't you?
Yes.
Is there any difference then in this?
No.
No difference.
So we're going to subtract the sine of theta. So we have 0 equals sine squared theta minus sine theta. Now what? Factor out a sine. I was just thinking that. I'm glad somebody else sang it besides me. Now what? Again, refer back to something that you could all do in your head automatically. How would you solve it from here? You set them both equal to 0. So over here, ooh, that's funky. There we go. You set it equal to 0. Sine theta equals 0, and sine theta minus 1 equals 0. Over here, you have the sine of theta equals 1, really.
Now we've taken a uber complicated equation and broke it down into two very simple equations.
Super simple.
Uber simple. So where is the sine equal to 0?
Sine is y, right?
Sine is y. Where on the unit circle is y
That's
equal to 0?
2 pi pi
0 and
0 pi
0 on one side of the circle, and on the other side of the circle, pi. So it's theta equals 0 and pi. How did I define it here? I guess you got to look carefully. I defined it as 0 less than or equal to pi, strictly less than 2 pi. So if it was less than or equal to 2 pi, you can call it 2 pi. Yeah. But so that side of the equation gives us just 0 and pi. What about sine theta equals 1? Where on the unit circle do you have a y value of 1?
3 pi.
Well, no, it's just pi halves, because at 3 pi halves at the bottom of the unit circle, the y value is -1. So
We get three solutions there: 0 pi and pi over 2. All this talk about pi. Jeez, I'm hungry right now.
aren't you as well hungry? Even better than pi right now would be big old Carl's Jr.
What are they?
What about both? A Western burger?
What's that?
A Western burger?
I don't. I go for the double Western now. I've kind of outgrown just a single Western.
I love the Western, dude.
Because according to their somewhat controversial commercial right now, 2 is better than 1. So you guys know what I'm talking about? Yeah, that, anyway.
I only go there for the green burrito. So, green, sick, go.
The moment the fight starts, I will make burrito salad. I'll grab his hand and like,
Grupping!
Take the pen for you.
We're going to get right into just a dang hard problem here. Graph y equals 2 sine of 2x minus pi halves plus 2. Whoa!
Yuck.
Well,
That's
geez.
what a thing.
You know what? I might have jumped the gun here. Should we start with this complicated one?
Let's do it.
Alright. You guys have spoken.
You gotta run before you
It's
get
just a phase shift, vertical line shift, and
Well, we've got to find like 7 different things here. Amplitude, period, phase shift. Does that sound familiar?
Yeah.
Phase shift.
Of course it does.
We've got to find the atomic weight.
What?
I'm just kidding.
yeah.
I'm just kidding. I'm getting mixed up with my classes.
So many atoms.
What's the nucleus weight, or whatever they call it in chemistry?
How many protons?
What's the amplitude?
16.
2. Where do we find the amplitude?
My
In front of the function. So
favorite.
the amplitude is 2. That represents the distance between the highest and lowest point, or half the distance, I guess, between the highest and lowest point. The amplitude is 2. Ooh, period. There's a teeny tiny little formula.
Something over something. Something over something. With a pi. There's a pi.
I don't know if I've heard it yet. Keep going.
There's 8 pi. There's 4 pi.
No, it's something with 2 pi.
2 pi
Dang it.
over b. Yeah, you got it. Good memory. Now, all of this stuff, I think, is in... I just got to double check. All this stuff should be in your explanation here online, I think I showed you. Sorry, I'm just searching. I'm searching my soul right now. It's not even. Is graphing? Oh, graphing's in here. Yeah, all of this stuff, all of these formulas, everything, it's in this little appendix that I put on the website for you to look at. But this is correct. 2 pi over b. What is b? In this case, b is 2. B is the coefficient of the variable. Okay. So this is going to be 2 pi divided by 2, which is pi. Now, the phase shift is always the one that gives people a little trouble. The phase shift. There is a formula you could use. It's hard to remember all these formulas. The formula is the opposite of C divided by B. If you're good at memorizing formulas, you can, I guess, remember that formula. This is your C value right here. So if we use the formula, then what's the opposite of C? Positive pi halves, yep. And then we're going to divide that by 2. Dividing by 2 is the same as timesing by 1/2, so this would be pi over 4. Now what you guys need to realize is this moves the graph to the right how far? Pi fourths of a unit. Now, if you're good at recalling formulas, that'd probably be the way you want to go. The phase shift is the opposite of C over B. If you're not really good at recalling formulas, which is probably more normal, most people aren't really good at remembering all these small formulas, this might be the way to go for you. I'm going to rewrite the function. Y equals 2 sine 2, and then I'm going to put another set of parentheses here. What if I factor out the x inside of its actual parenthesis? And then I'm going to have x minus what? Pi fourths.
Now looking at it that way, looking at it this way, I forgot something, the plus 2.
The plus 2.
Looking at it this way, what does that minus pi fourths really mean? It's a phase shift of what? To the right, how many? Pi fourths of a unit. So you can either find the phase shift using this formula, or you can factor out the b value and use the transformation type of graphing. So it moves to the right pi fourths, it moves up
2 units. So anyway, we are ready to graph.
Yes, sir.
I love coach.
Everybody hates Coach Graph.
So, depending on who you had last year as a pre-calc instructor, they might have shown you a little bit differently. The way I showed my students was to consider the transformations. It's not only moving to the right pi fourths, what else is happening? It's also moving up 2 units. So I'm going to perform that transformation. If this is pi fourths, and this is 2, then I'm going to go to the right pi fourths and up 2. And I'm going to draw a new set of axes around that point right there. So rather than transforming the graph, I transform the axes. Ooh. So I've got a new coordinate system right there, centered around the point pi fourths, comma 2.
They have a new origin. So starting from that origin, what was the amplitude? What was the period? Pi.
So I'm going to go a horizontal distance of pi on the new axis. So I'm just going to arbitrarily say, all right, over here is pi. But on the original x-axis, how far out are we really?
Because I started at pi fourths and went on a distance of pi on the new x-axis. On the original x-axis, we already started at pi fourths. Went over a distance of pi. Pi plus pi fourths
is 5 pi fourths. So we really ought to call this 5 pi fourths because that's really the location. Okay. Now, what is the period, by the way? What the graph is a period on a trig function? The horizontal length needed to complete 1 full cycle, right? So between this starting point and this ending point, you're going to graph 1 full cycle of the sine function. How high and how low are we going? 2. So from here we got to.